All right, so today we'll continue with our uh, chemistry study questions and answers. So here we are, number 6. So it says, how many grams of aluminum chloride can be produced when 0.100 moles of aluminum reacts with excess chlorine? Okay, so the balanced equation we have is that Al2 plus Cl2 3, that is 3 of it, 3 chlorine or 3 chloride, then giving me 2 moles of non-chloride. So this is what I have. Now they're asking me to get, they said can be produced when, okay, 0.100 moles of this reacts with excess chlorine to produce, and what they are asking me is how many grams of this aluminum chloride. So I told you, always focus on what you are asked to find, that is gram of this, what you're asked to find, and what you're given. I'm giving 0.100 moles of this, so this is what I'm giving. Always focus on what you're given against what you're asked to find. So in this case, I'll now ask myself, the ratio of aluminum to aluminum chloride here is 2 is to 2. That's the ratio. It's 2 is to 2. Now I'm giving 0.100 moles of this, and I don't have any mole of this, so I call it x moles. So when I cross multiply, I now have that this is 0.100 times 2 equals to 2 times x. Understand? So that if I do the maths very well, oh god, so if I do the maths very well, this will give me this should give me, let me punch it. If I do the maths very well, this should give me 0.2 equals to 2x. So that making x subject of the formula, I divide both sides by 2. This will cancel this now. So that this will now give me 0.1 equals to x. So that is the mole. So but you recollect that for us to find mass, anytime we are finding mass, we use this formula. Mole, I gave you 5 formulas of mole. So mole equals to mass over molar mass. So that placing what we have 0.1 mole for aluminum chloride, because this x now means that this is 0.1 mole for aluminum chloride. So I have 0.1 mole for it, but I don't have the mass. So, and the molar mass of AlCl3 is going to be 27 for aluminium, plus chlorine is 35.5, so times 3. So this is the same thing as having mass all over. When you do this, when you do the punching, you have everything here to be 27 plus 106.5, which gives you mass all over 133.5. And when you have that 0.1 equals to gram all over, mass is gram, 133.5. So anything standing on this one is over 1, cross multiply, you have that this is the same thing as 0.1 times 133.5 equals to gram times 1. So gram, the gram of it is going to give us 13.5. It should be 13.4 actually. 13.4 rather. So that means this is the gram of this that we'll have. So mass is equals to, you know that the unit of mass is gram. So that is how you go about it. So let's move to number 7 question. All right, before we move to number 7 question, Let's tackle 6b. So 6b says, what is the percentage yield of this reaction if 12.5 grams of AlCl3 are actually obtained? Whenever you hear percentage yield, know that it's talking about percentage yield. Whenever you hear percentage yield, know that it's talking about something called actual yield all over expected yield. Expected yield is also called calculated yield, or you call it theoretical yield times 100. This is what percentage yield is all about. So whenever you hear percentage yield, notice that in this question now, they are telling us that we should find the percentage yield of this reaction if 12.5 grams of this AlCl3 is obtained. So whatever you're giving here is called the actual yield. It's called the actual yield in the sense that if I have an experiment going on, let's say this is a machine, and I impute my reactants here, and at the end of the day, let's say I have A plus B, and at the end of the day, this machine gives me 0.3 moles of AB, but I was expecting full 1 mole of AB. So what this machine give me is my actual yield. That is what you have here. So this is your actual yield. Actual yield. But what you are expecting, or what you calculate from your expectation, you calculate it how you want it. So what you're expecting is what we call theoretical yield. So that means that in this question, knowing what we know from this question, remember we got that this one is 0.1 and the rest. So let's solve. So knowing what we know from this question, let me bring everything down. I'm using these ones to explain to you. So let me bring everything down so that I have 2Al plus 3Cl2 giving me 2AlCl3. Now, the ratio I have here is 2:3:2. Now, whenever you hear yield, it means on the product parts, what have you produced? So for that reason, the ratio 2 moles of aluminium will always react with 3 moles of chlorine or chloride to give me aluminum chloride, which is 2 of it. So if I have this, now this is the ratio. Now the next thing I need to check is which one is the limiting reactant. The limiting reactant is what you compare, or should I say what you make use of to compare the yield to get the produce, the lowest possible way to avoid wasting. Notice the question said that this aluminum reacted with excess of chlorine. So this is the excess reactant. We are not going to make use of the excess reactant. So we'll make use of the limiting reactant against this. So that means that 2 moles of this will react with this to give us 2 moles of this aluminum chloride. While if you check that question, when we finished solving, if you check at a point, percentage of this reaction will give us 12.5 grams and actually obtained than the rest. So when we finish solving, we got that 2 moles of this is now reacting with 2 moles of this. So it's simply percentage yield. Whenever you want to find percentage yield, you must first of all, from the given stoichiometric equation, compare. It is something that has to do with comparing the limiting reactants with the products. Whether it's not about solving stoichiometry now, finding mass to mass or whatever, where I tell you compare given and what you're asked. In this case, the products must be there because that's your yield against limiting reactants, the one that has the lowest mole, the least mole, or the least wastage. So if I have that, this is my limiting reactant because this one said in the question, it was said that this is in excess. So look at it here. Look at the question, if you remember. On 6, they said how many grams are produced when aluminum reacts with excess chlorine. So with excess chlorine, so is the excess reactant. So for that reason, Now I will say, since 2 moles of this reacts with this, then let's check. There's a part in this question where they gave me 0.100 moles of aluminum reacts with excess chlorine. So 0.100. Remember I said percentage yield. Whenever you are doing it, before you start making use of the formula, you must, from the stoichiometric equation, always compare the products with the limiting reactants. So 0.100. Now this 0.100, if you notice, it gave us, they said that in the question that this 0.100 yielded a product that is 12.5 grams. Are actually, what is the percentage of this reaction if 12.5 are actually obtained? But notice that in this case, in this question, they are telling us that we should find the percentage yield. What is the, if 12.5 grams are actually obtained? So that 12.5 gram, I'm supposed to say 0.100 gives me 12.5 grams. But this 12.5 grams that he gave me, that is giving me, is for when I do the experiment. That is my actual yield. But when I'm not expecting everything to be okay, that is the way it should be. I'm expecting 100%. When you're doing this thing, you're expecting 100%, but at the end of the day, maybe the machine or the product, or because of exposure to air, it didn't come out 100% the way you want it. So I want to check that thing called theoretical yield, also called calculated yield. So instead of saying this in the question, they said it yielded 12.5 in that question. But when I'm finding theoretical yield, I will call this product part X. So that if I compare these two now, this will now be 0.2, then this will now be 2x. So x will be equals to 0.2 divided by 2, which is the same thing as that's 0.1. So this my calculation is my theoretical yield. This is my theoretical yield. So theoretical yield, when it's finding moles or stoichiometry, you're always comparing with regards to maybe what you're given against what you're asked to find. But once they ask you find percentage yield or theoretical yield or whatever they're asking you to find, when you are finding theoretical yield, it will always be the products against the limiting reactant. The limiting reactant is simply the one that has the least mole. In some cases, you will have to find it by doing the given moles given to you divided by the stoichiometric coefficient. Assuming they said that this is 0.2 moles, that he came with 0.2 moles and this one came with 0.3 moles, I would have said 0.2 moles divided by this stoichiometric coefficient, which is 2, 0.3 divided by 3. But since already they told me this is in excess, that means it's my limiting reactant, I will always compare it the way I normally find my mole to mole. So once you find it, you find the mole. So this is my 0.1 mole, and that is my theoretical yield. Now my actual yield has to be in mole. It has to be in mole. This is supposed to be, this formula, percentage yield is equals to mole, that is mole of, or should I say actual yield mole, or you say mole of actual yield all over mole of theoretical yield times 100. So actual yield is supposed to be in mole. So this means that 12.5 gram given to me in that question, I have to convert it to mole. And to convert this to mole simply means that we know that mole is equals to mass over molar mass. And molar mass they are talking about here is that of AlCl3. And we know that AlCl3, that's the molar mass of AlCl3 is equals to 133.5. So this means that this is the same thing as saying 12 all over 13, 133.5. So that means if I do 12 divided by 133.5, I will get, I just hope I'm correct. Okay, it's supposed to be 12.5, sorry. It's supposed to be 12.5 divided by 133.5. So that is what we are given. Sorry, it's supposed to be 12.5. 12, I'm trying to rush because of time, so I don't continue to take time. 12.5 divided by 133.5. So this will give me 0.0936. So this is my actual yield. Mole is going to be mole. So because if you check it, this is gram, this is gram per mole. So this will cancel. So it will give me mole. So percentage yield now is equals to mole of actual yield all over mole of theoretical yield times 100. That is 100 in percentage now, 100%. But I don't want to put this because it's already having percentage here. So this is going to be actual yield mode is 0.0936. Theoretical yield mode is 0.1 times 100. So when you do this, when you do the punch, you have that this is 0.0936 divided by 0.1 times 100. So you're getting 93.6%. That's your final answer. Thank you. So the key thing is to understand that whenever they ask you about theoretical yield, it's all about comparing limiting reactants with the products. Actual yield is what you are given in that question, the gram or mole you are given in that question. While percentage yield is always going to be this formula you're making use of. Thank you. So number 7 says, what is the molarity of copper 2 chloride solution if 10.0 grams of copper chloride, copper 2 chloride, are dissolved in water to give 250.0 milliliter of solution? The molar mass of copper 2 chloride is 134.5 gram per mole. I need you to know that molarity is the same thing as concentration, and it is equals to amount in mole all over volume of solution.